Ben Pearson, the Roadster Tracker. One of the ideas that I see a lot of interest from time to time in the field of space exploration is space-based solar power. Specifically, you have solar panels that are in space, so they don't take up valuable land on the ground. You're not having to kill large acreage to put them there and have these kind of barren types of things there. So you put them on the ground, you broadcast down their power using some kind of microwave technology. And the reason why you use microwaves is because they're not absorbed very easily by the atmosphere. And so they make an excellent choice for this kind of thing. And then on the ground, you have a large antenna array that will basically suck up this power and put it into the grid. It all sounds great, but to make this work, you have to have a lot of stuff. And so let's talk about some of that. First of all, most of the interesting things that I've found have been on a few papers that have been published on this subject. One of the big things that I saw that makes a lot of sense is you want to place these in geostationary orbit, because then they're always over a fixed point on the Earth, and that just makes everything easier. If you have a satellite TV, you're basically pointing your antenna dish straight at the satellite. You don't ever have to move it. It's fantastic. It works great for this kind of telecommunications approach. And it works best when you don't really care about the latency, and for power, you really don't care of latency on the order of a few tenths of a second. Not a problem at all. So where do the problems come into play? Well, first of all, you need ginormous antennas. You need a 10-kilometer diameter antenna on the ground. That comes out to be about 6 miles. That's a good size. This is actually larger than the largest solar arrays that we have here on Earth. Very considerable area, but it's not a huge amount. And you do actually get more power out of one of these than you do from a solar array of comparable size. You'd get about 5 gigawatts of power out of this array, and that would be compared to, I think, 2 or 2.5 gigawatts out of a similar solar array. Now, part of the reason why you get less in the solar array is you get more at a peak. With the microwave system, you can have it in effect 24/7, theoretically, with a very small exception that happens during the fall and spring at midnight, where it just so happens that the Earth, the Sun, and the satellites in geostationary orbit will all undergo an eclipse season, as it's called in the industry. Basically, they'll go behind the Earth's shadow and they'll lose power. But that's a very small portion, and that's not a huge concern for the most part. Let's keep studying this even further. Well, we have this ginormous array. In order to do that, you have to have a 1-kilometer array of antennas on orbit, and it has to all be one continual thing. You're not going to work very well if you're trying to put a bunch of smaller systems together. This would produce the 5 gigawatts of power, roughly. You actually need a little bit bigger solar array than you need the antenna, but it's not that big of a deal, and you can kind of build them together and kind of piecemeal them into place. In order to lift that much solar panels, you're talking on the order, let's just use Starship, because this is frequently mentioned as a use case for Starship. You would need 100 tons per Starship, let's just say, and you would need probably 4 or 5 Starship missions to refuel these to get them into orbit. So let's just call it 5 missions for each set of these. Each one of these would be able to carry solar panels that would work in space, maybe a tenth of the array. That's probably somewhat close, maybe not even quite that much. That's still 50 Starship launches, which means that you're going to have a cost that is fairly considerable to launch all of these. And in reality, you probably need a lot more than that. I'm probably underestimating this by a fair bit. You'll be able to use some higher efficiency solar panels, which you will in space, than you would on the ground, because it's expensive to launch them. You want to launch the best, but still, this is going to require a fairly considerable space station. Then you have to maintain it there. That will require quite a bit of ion thrust. To maintain a geostationary orbit takes active work from a satellite. Otherwise, it'll start to bounce around back and forth and not really do a lot of good things. Okay, so you have this solar array that's on orbit. Then what would this array look like? Well, there's a couple of possibilities. First of all, you could have them be able to dynamically point their antenna at any point on Earth. This would be ideal. A couple of things. You could actually theoretically point at 2 different cities that would be able to power where the peak power is at a different time of the day. You could point at New York and Los Angeles, for instance. And at the peak power point of day, it actually costs more power, more electricity to make that work because a lot of people are doing it and you have to have these on-demand types things. That is a unique capability compared to solar power. But it still, has its issues. And you can only do this so much, but you could probably get a decent amount of power out of this by using these 2 different zones and increase the power. And, say Texas has a particularly cold day, then they could focus all of their power down on Texas. It sounds great, but it still, has its issues. These antennas having to be movable will increase the cost considerably. To have an antenna that can point 45 degrees while keeping the solar panels all pointed in the same direction, that takes a mind-bogglingly large amount of power. And if you can kind of put these a little bit more fixed so that the antennas are always pointed towards the Earth, that you would want to fix constantly. But the solar panels, they don't always have the same amount of power. You can actually condition these so that they fit the peak power of the particular area that you're trying to power. And then it's, probably reduces the cost by 50% or even more. And that may just be better to launch multiple of these arrays to make that happen. But these solar powers, they're going to have all kinds of issues. If you're having to launch 100, 200, 1,000 launches to make one of these arrays, you're starting to get into the cost of a nuclear power plant. And as you guys probably know, in my opinion, nuclear power is the best power that's out there. It's very efficient. You're still having to eat up a considerable amount of land to make this work. The amount of energy that's transmitted onto the site is only about 80% of the energy. So you're going to have a kind of keep away zone buffer around there because you're going to have a higher than normal microwave count. Now, this isn't going to be that significant. It would increase the total amount of energy by 5 to 10% over this area, which isn't that much, but still, 10% hotter sun over a particular area, it's going to be hot, and this will be in microwaves that'll be invisible to you. So it can't be that pleasant. Overall, it's a really interesting concept. I think there are better ways out there, but we'll just have to see what those end up being. I don't think this is the wave of the future. I still think that nuclear power is going to get us there, but maybe in the distant future when we can manufacture these things on orbit itself and broadcast the power back to the Earth, that may be theoretically possible. And that's honestly more than I thought would be possible when I started researching this video out. I thought it was completely crazy. I was playing around with the wonderful simulator Universal Sandbox, and you can actually have a laser beam that you're pointing straight at the Earth to see what kind of damage this would be. And I put like 10 times the power requirement of all of Earth into this laser beam, and it caused a little bit of warming, but it wasn't that noticeable. So this would be a better way than global warming, but it still seems like broadcasting extra energy to Earth isn't exactly the thing that we want to be doing right now, especially if you're looking to solve the global warming problem. I could be wrong in this. There's probably something that I'm missing, but I still am of the opinion that there are other sources of energy out there better. Thank you guys so much for everything. Let me know whatever questions or comments you guys have. Until next time, keep on tracking. Take care.